So in 7.5, doing some hypothesis testing, let's look at question 13. This one had a wrinkle in it that we like to look at. So the measurements of the diameters in inches of 12 chosen golf balls are listed. So at a level of significance, in other words, alpha is equal to 0.05, is there enough evidence to reject the claim that the standard deviation, and remember standard deviation is sigma. So is there enough evidence? Let's see if we get this thing to cooperate with us here. Is there enough evidence to reject the claim that the standard deviation of the measurements of these diameters that's an equality, is equal, in other words, so 4 thousandths of an inch. So is there a standard deviation of 4 thousandths of an inch between golf balls? So again, this was the population standard deviation. So what they're saying is sigma equals 0.004 or 4 thousandths of an inch. So as we move into the question, they gave us some data of the 12 golf balls. They don't actually give us the sample standard deviation. They give us the data that would help us calculate the sample standard deviation. So we have a little bit of work to do there. And I'm going to show you how to do that with a calculator. So the first question says, write the claim mathematically and identify H sub 0, the null hypothesis, and H sub A, which is the alternative hypothesis. Choose the correct answer below. So since we have the claim is the standard deviation of measurements is 4 thousandths of an inch, we kind of pick up on B. So the null hypothesis is always the equality. So the population standard deviation is 4 thousandths of an inch. That's the claim. And remember the counter side of that, the complement, the alternative hypothesis is going to be sigma does not equal to 4 thousandths of an inch. So since this is an equality, notice how this is a two-tailed test. So you'll have to figure out what chi-squared L is and what chi-squared R is. So you have two regions here since it's an equality. So we have a right tail, and then we have this left tail. So those are going to be our rejection regions. So the first thing says find the critical value or values. So since this is a two-tailed test, we're going to have two of them. So we actually have to find this chi-squared R and this chi-squared L. Now remember, since alpha is equal to 0.05, we have to use half alpha. So we have to divide that by 2. So half of that would be 0.025. So 1/2 alpha would be 0.025. So using the table, chi-squared R, remember, is the right side of the table. So this side is, doesn't like me to do two documents at once. So come on now, get the right document here. So apologize here, but this is the chi-squared R side, and then this is going to be the complement or the chi-squared L side. So once we find chi-squared R, we can then locate chi-squared L. So remember, to do the table, we need to know the degrees of freedom, which is one less than the sample. So I believe our sample was 12, so our degrees of freedom was 11. And so chi-squared R is actually going to be this 0.025. So if we come down here, we're seeing 21.920 is one of the values. So 21.920 is one of the values. And then since that was 3 this way, symmetry, we go 3 the other way, or in other words, 1 minus half alpha, which is going to give us this, so 1 minus 0.025, if you will, is going to be this 0.975. But instead of doing the math, we can just see symmetry. So if we have this 0.025, then we're going to have this 0.975 for chi-squared L. So if we go down to degrees of freedom 11, we're seeing 3.816 for this example. So our critical values are going to be this 3.816 and this 21.920. So if we look at our graph, again, this is just roughed out. Remember, zero's here, so 3.816 is going to be over here. And over here is going to be then the 21.920. So if we're right of 21.920, and if we're left of 3.816, we're in the rejection region. So we'll reject the null hypothesis, which also is the claim. So if you notice, our graph was going to be this A because since we have an equality, since our null hypothesis is an equality, we have two rejection regions. So A is going to be your answers. It looks like it goes by fives, 5, 10, 15, 20, 25, 30. So notice how it's a shade less than 5, which is 3.816. And it looks like it's between 20 and 25. So 21.920 is between 20 and 25. So that checks out on the graph. So as we move along here, it now wants us to find the standard test statistic. So the standardized test statistic, what we have to do is use our calculator and put the data into the calculator. So we need to put this data into the graphing calculator to determine the standardized test statistic. So using my calculator, if we go to stat, got to turn mine on evidently. If we hit stat and then go to edit, I can enter the data into the calculator. So I've already done that. So now if I go to stat, slide over to calculate, I can then now calculate, notice how it lists one there. So I can calculate my statistics. So the mean would be 1.683. The other numbers we're seeing here is the sample standard deviation is this 0.0022, all that. And the population from there is that one. But since we're doing a sample, S of X is what we need. There is more stuff here. So if we scroll down, it gives us the quartiles and all our stuff. But all we really need to find the standardized test statistic is we're going to use this S of X. So remember, the formula to find the standardized test statistic is going to be the degrees of freedom, which is n minus 1, times the sample variance divided by the population variance. So the population variance was given to us. The population variance is this 0.004. So if I come back down here, our I'm sorry, our population standard deviation was 0.004. But to get the population variance, we'll have to square that. So as we move through this, the degrees of freedom is going to be the sample size minus 1, so it's going to be an 11. The sample variance, again, I'm going to use the calculator for this, so I'm going to have this S squared here. And then I'm going to divide that by this 0.004 squared. So on my calculator, what I could do is quit there. So I can type 11 in and I can multiply by, and I'm going to use the actual variance in my data. So if I go to vars, number 5 is statistics. If I choose that, I can choose the sample standard deviation, I should say, number 3 there, the sample standard deviation. But I got to square that to get the sample variance. And then if I divide that by then the 0.004 squared, that will be the population variance. And that will give us then this 3.417. So our standardized test statistic is going to be then this 3.417 if I round it to three decimal places. So our next question is then decide whether to reject or fail to reject the null hypothesis. Well, 3.417, remember up here, if you're left at 3.816, you're going to be in the rejection region. 3.417 would be left of 3.816, so we are in the rejection region. So we are rejecting H0 because the standard test statistic, this 3.417, is left of that 3.8 number. So what do we do from there is make a decision. Is there enough evidence to reject the claim at a 5% level of significance? Well, yes, there is. Since we rejected the null hypothesis, there is enough evidence to reject the claim. So remember, we have this little thing here. So if we reject the null hypothesis and the claim is the null hypothesis, what we're saying is there is, sorry, we rejected the null hypothesis. Sorry. We rejected the null hypothesis and the claim was the null hypothesis. There is enough evidence. There is enough information to reject the claim. So we kind of see that all play out there. So hopefully you find that helpful to do that last question in 7.5.